Here we are going to see how to convert speed time graph into a distance time graph. For this, we have divided speed time graph into different parts, and then we have found the area of these different parts here. The area of the first part is 15, and the area of the first and second part both. The second is rectangle and the first is triangle, and the sum of these two is 55, and the sum of all these three is 70. Here you can see that in the speed time graph, the first part shows the speed is increasing, okay, up to 10 meter per second. It is increasing steadily. So the corresponding distance time graph will be a curve look like this. Here the graph is increasing, its gradient, its steepness is increasing. So this is the corresponding graph of this. So how to find this value 15 here? For that we have to find the area of the first portion of speed time graph, which is 15. So this will be 15. In the second part, the speed is constant here. Okay, the constant speed mean the distance time graph will be a straight line, and it is a rising straight line because distances keep on increasing. So what is the corresponding value 50? How did we get this 55? So we have found the area of this rectangle and this triangle. The sum of these two is 55. So area under the graph of speed time graph is basically a distance. So this is 55. In the third portion, the speed is decreasing. It is decreasing steadily. Okay. So the graph, corresponding distance time graph will be a curve in which the steepness is decreasing steadily, and steepness of speed time graph is gradient, that is speed. So speed in this portion is decreasing steadily up to 0. And the total area of all these three portions of the graph is 70. Therefore, the corresponding value on the y-axis is 70. This is how we have converted the speed time graph into a corresponding distance time graph, and how we have found the y-axis value using the area of different portion of speed time graph. In this part of the video, we are going to see how to convert distance time graph into a speed time graph. The first part of the distance time graph shows it is a curve, and the steepness of the curve is increasing. The steepness of the distance time graph is gradient, and gradient is the speed here. So therefore, the speed is increasing here. To find the gradient or speed of the curve, we have to draw the tangent and then find the gradient of that tangent line. Suppose the speed is increasing, the steepness is increasing steadily. That is, speed is increasing steadily. So at the end of the 5 seconds, the speed is suppose 60 meter per second. So it will be 60, a straight line up till now. In the second part of the journey, the distance time graph remain straight line, and the gradient of straight line is gradient, and the gradient of straight line is always constant. Therefore, in the second portion of the journey, the speed is constant. To find the gradient of this line, we will use rise over run. The rise is 700 and the run is 10. So the rise is 600 and the run is 10. So 600 divided by 10 is 60. It means that the gradient of this portion is 60. That is, the speed is 60. So speed remain constant here. In the distance time graph, the gradient is constant. So speed is constant. So for 5 to 15, the speed remains 60. In the third portion, the steepness keep on decreasing. So the gradient is keep on decreasing. So speed is decreasing until the line become horizontal, and the gradient of the horizontal line is 0. So speed becomes 0. So it will start decreasing till 20 seconds. This is the graph of the third portion of speed time graph. And in the fourth portion, for the last 5 seconds, the distance time graph become horizontal. If the steepness of the horizontal is 0, so the gradient is 0, the speed is 0. So for last 5 seconds, speed remains 0. So this is 0 speed for the last 5 seconds.